Hello and a very good day to Dr. Azian and others. Today, me and my group, which is Group 5B from Section 5, will be presenting our Thermofluid Engineering Laboratory Report. And our topic today is about fluid density measuring method comparison. So, for our introduction, in this experiment, we focus on Archimedes' principle and the barometer experiment of measuring fluid density. We will find which method is the most accurate in this project. The experiment is focusing on two types of fluid, which is water, oil with significantly different densities. Throughout this experiment, we can truly understand these physics principles and try to apply these principles in the real world problems.
Hello everyone, my name is Darwin Raj. Right now I'll explain about the objectives. Firstly, it is to determine the density of oil and water. Secondly, it's to determine the most accurate method and the most easiest method to use in measuring the fluid's density. Now we'll talk about the theory. Well, Archimedes' principle has stated that when an object is submerged into a fluid, well, the weight displaced is equal to the upward buoyant force. Well, for an example, if you put an object into a beaker, the weight that the water displaced is equal as the buoyant force as well. Well, a barometer measures the atmospheric pressure by balancing the weight of a liquid column against the pressure of the liquid surface. Well, for the atmospheric pressure, it pushes the liquid upward in a sealed tube until its weight equals to the pressure, with the height of the column indicating the pressure. Well, for now, we would like to talk about how to archive the density fluid. Well, we will apply the absolute pressure formula, which is stated down there.
For our procedure for test 1, which is the measuring method experiment, we started off by placing 200 milliliters of water inside the measuring cylinder. We then take the electronic balance and record the mass of the 200 milliliters of water. We then repeat step 1 and step 2 with 400 milliliters of water and 600 milliliters of water. Lastly, we repeat step 1 to step 3 with oil and record all the data inside the table. Okay, for our second procedure for test 2, which is the Archimedes law, we take each stone mass and measure the value and record it into our table. We then fill the eureka can with water. After that, we take 5 stones and that we pick and measure before placed into the eureka can. The water then overflows and coming out is collected and measured the volume by measuring cylinder. The experiment is repeated from step 1 to step 3 with 10 stone and 15 stone. Then the value is recorded into the table. We lastly then repeat step 1 until step 4 with oil and all the value is recorded. Okay, so for our procedure for test 3, which is the barometer experiment, we started off by taking the big container and 2 meter transparent tube and fill it with water before experiment started. Then the 2 meter transparent tube is placed into the big container and being stabilized with retort stand. The height from the surface of water until the peak of water in transparent tube is measured and recorded. We then repeat step 1 until step 3 for 3 times and all value is recorded into the table. Lastly, we repeat step 1 until step 4 by replace the water with oil and we record all the value inside the table as well.
So next we come to the result for our test one. So in this slide we can see that there is two tables here. First table is the exact error table for the water density, and the second table is the exact error for oil density. So about the experimental density calculation we have put into the slide before this. So in here, because our experiment is mainly focused on uh, which method is the best method to measuring the density of a fluid. So we mainly focus on the exact error of each density for every test. So in test one, we can see that the average exact error of air water density is 0.71. I believe this is a very low number, and we can see here the first and second error is 0.65, and the last one is 0.82. So we can conclude that in most of the situation, the phase this will be the very accurate data. So for the oil density, we can see that the error is higher. So the average error will be 4.52. As we can see, then for each one will be 5.57, 5.02, and 2.98. So this for this situation, we can see that if our have a correct precaution and correct step, we can increase and reduce the errors. So we can still can conclude that this is a quite efficient and a very accurate method, because you see that the total value is just 4.52, is less than 5. I believe that this is still a relative low error compared to others method. Now we come to the result for test 2, which is the Archimedes laws method. So in this method, same as the before, we put the experimental density calculation in the slide before this. So in here, we mainly focus on the exact error for water density and oil density. In this method, we can see that this for the oil density, water density, the average exact error is 4.80, and we can see that for each number will be 3.51, 6.40, and 4.57. So we can see that if because at the centers one, the repeated second times, we can see that our step I believe has some errors. So cause the error is highest. If we only take the first and the last one, it's relatively about 4%. So I believe that this is still a accurate experiments method. So for the density, we can see that the final number will be final average exact error will be 5.80. So we can see that for each average number will be 9.73, 2.45, and 5.21. So in this case, we can see that the number is quite fluid. So we need to make sure our every step is very correct, very perfect in this experiment method, in order to make sure it is very accurate compared to the first method. So now we've come to the third test, which is the barometer method. So same as before, we put the experimental water density and experimental water density calculation in the slide before this. So here we only focus on the exact errors for these two fluid. So we can see that in this method, the average exact errors is completely our mind, because for the water density, the average exact error is 432.87%. For the oil density is 481.43%. So why cause this is because we actually have not enough research, and we use only 2 meters pipe. And finally, when we carry out the experiment, we found that the 2 meter pipe actually is not really enough for the barometer to extend the whole pressures, but we still can manage to continue the experiment. So we just carry on, and after the experiment, we done the calculation. We found that the error number is totally went off. So we also did more research and found that actually it's need a very long, very straightforward, straight tube. Is parameter, the actual parameter actually not a simple thing that we can actually can manage of. So in this experiment, because our main objective is still want to determine which method is the best method, so we still put in here. And as we can see, the number actually tell us this is not a good experiment to measure the density. This we will talk more in discussion part.
Moving to the observation, in the Archimedes experiment, some of the glass marble we brought had cracked and some glass debris. Therefore, we temporarily changed the glass marble to stone from outside the lab. In the last barometer experiment, fluid inside the test tube weren't poured out into the big container. To deal with that, we borrowed a 2-meter long transparent water pipe and replaced it. Luckily, it worked well. We predict the test tube having a big width cause the fluid need more pressure to put the flow out of the pipe. Moving to the discussion, For the graph of test 1, the volume is directly proportional to the mass. For the test 2, the reciprocal of mass of stone is directly proportional to the reciprocal of volume. For the graph test 3, which is the graph of repeated time versus the height of fluid, the graph shared a big weight. Well, for the average exact error of water and oil density, the error is increasing, followed by the test 1, test 2, and test 3. Test 1 and test 2, both line of water and oil got interception. For average exact error in measuring method, this method is accurate. Both density for test 1 and test 2 has less than 5% of error, while test 3 has bigger error. This is because our 2-meter transparent tube did not enough length to measure. This value tells us that our experiment has some error occur and cause the value is not accurate. For Archimedes law method, the witness is need to be extra careful when dropping the stone into the water to avoid extra fluid coming out. While the barometer method, we need of a long and straight tube which need a special holder to hold it in position. So we come to a conclusion that measuring method is the easiest way to use and most accurate.
In conclusion, this experiment is a success. We have successfully proved the measuring method is a good way to measuring various fluid of density with high accuracy and less possible error. This can be seen from test 1 since the average exact error of this method in measuring the water density and oil density is 0.71% and 4.52%, which is a minor error. Through this experiment, we learn how to design and conduct experiments with specific objectives. We also apply physics concepts such as Archimedes principle and the barometer's operation. There are a few recommendations to improve our experiment. One of them is adding various types of fluid in order to test whether the method we are using is suitable all across the fluid or is certain type of fluid. The test method can be also increased to ensure the method we are using is the best method to measuring the density of a fluid. The number of samples of experiment need to be increased to reduce any possible errors during the experiment. In the barometer experiment, use the tube as long as possible to ensure there's enough pressure to pour the fluid out of the pipe. Thank you so much for listening our presentation. Thank you.